Hello everyone. Before diving into today's topic, we want to take a moment to thank you for your support. Every like, comment, and subscription truly makes a difference and helps this channel grow. If you enjoy our content and don't want to miss upcoming videos, subscribe to the channel and activate the notification bell to receive all updates. In the eternal silence of the lunar night, as shadows stretch sharply across the dusty ground, an idea slowly takes shape, to transform that desolate landscape, made of craters and regolith, into the beating heart of a new extraterrestrial industrial civilization. Just a few decades ago, such an image might have drawn a smile even from the most optimistic of space visionaries. And yet today, halfway through the 2020s, the industrial colonization of the moon is no longer mere science fiction. It's a concrete, structured project with multi-billion-dollar investments, cutting-edge technologies, and precise deadlines. To understand the ambition behind this new lunar race, we must start with a simple physical truth. The moon, with gravity just 1/6 of Earth's, is the perfect springboard for humanity's expansion into deep space. Launching payloads from Earth is expensive and complex. Doing it from the moon, using local resources, could drastically cut down on time, costs, and risks. It's this perspective that has convinced governments, companies, and space agencies to focus on our natural satellite as the first real logistical and industrial base beyond Earth's atmosphere. But how do you build an industrial civilization on a celestial body without an atmosphere, subjected to extreme temperature swings and constant micrometeorite bombardment? The first step is infrastructure. And here, today's technological arsenal comes into play. Heavy landers like Blue Origin's Blue Moon, capable of delivering tons of cargo to the lunar surface. Interplanetary rockets like SpaceX's Starship, designed for reusable transportation of materials and personnel. Pressurized living modules 3D printed using lunar regolith as building material. Every component is envisioned not as an isolated prototype but as part of a broader ecosystem that includes abundant solar energy, in-situ extraction and refining systems, and, no less importantly, a permanent communication and navigation network. Water is one of the key resources around which this transformation revolves. The lunar poles, especially the South Pole, are rich in deposits of water ice buried in permanently shadowed craters. From that ice we can derive not only drinking water for astronauts but also oxygen and hydrogen, essential fuels for rocket engines and human survival. The idea of producing fuel directly on the moon represents a paradigm shift in space logistics. Imagine a network of refueling stations in lunar orbit or along the route to Mars, powered by lunar fuel, reducing reliance on Earth-based supplies. Alongside water, the moon also holds mineral resources of enormous interest: titanium, silicon, rare earth elements, and helium-3. The latter, in particular, is seen by many researchers as the holy grail of future energy. A rare isotope on Earth but abundant on the moon, potentially usable in nuclear fusion without radioactive waste. If we ever manage to develop efficient commercial fusion reactors, lunar helium-3 extraction could become an inexhaustible source of clean energy for the entire planet. But the moon won't just be a mine to exploit. The architects of this new space era envision it as a laboratory for the most advanced technologies. Modular habitats tested for hostile environments, autonomous robots capable of operating for months without maintenance, 3D printing systems to produce spare parts or entire structures on site. Every innovation developed to withstand lunar conditions could have immediate applications on Earth, from ultra-resistant materials to sustainable energy technologies. The heartbeat of this revolution will be made up of permanent settlements, hybrid bases, both automated and manned, capable of hosting technicians, engineers, and scientists. There's already talk of small nuclear reactors to be installed beneath the surface, to provide constant energy even during the long lunar nights, which last 14 Earth days. Plans include hydroponic greenhouses to grow crops in controlled environments, closed-loop recycling systems for water and oxygen, even electric transport vehicles designed to traverse craters in microgravity. Behind this hyper-technological vision lies a profound geopolitical and philosophical dimension. Whoever controls lunar infrastructure will control the future trade routes of the solar system. Those able to establish a permanent presence on our satellite will hold technological, industrial, and cultural primacy in the space expansion era. That's why, in recent years, we've witnessed an unprecedented race among space powers: the United States, China, India, Russia, Europe, Japan, each with their own programs, ambitions, and strategic alliances. Yet this competition isn't solely political. Something deeper drives humanity toward the moon, something beyond economics or military logic. It's the ancestral pull of a world that's close yet unknown, watching us for millennia in starry nights. A world that, for the first time in history, could become a second home. If the first phase of lunar colonization focuses on survival and self-sustainability, the second, already outlined in several ongoing projects, envisions the creation of true extraterrestrial industrial districts. Imagine assembly lines in microgravity where satellite components or scientific instruments are built directly in space, ready to be launched into Earth orbit or toward more distant destinations. Or advanced printing centers, capable of producing composite materials or metallic elements without Earth's gravitational limitations. All of this is theoretically possible on the Moon, where environmental conditions and local resource availability allow for experiments unthinkable on Earth. One of the most fascinating applications involves the production of advanced optical fibers like ZBLAN, zirconium, barium, lanthanum, aluminum, sodium fluoride, which on Earth suffers from structural imperfections due to gravity. In the lunar environment, a purer material with extraordinary optical performance could be produced, ideal for telecommunications and quantum data transmission. And this isn't mere speculation. Private companies and space agencies are already testing mini-laboratories in orbit and preparing the first lunar manufacturing experiments for the next decade. Alongside this industrial scenario, social and cultural developments of epochal scope are emerging. Living and working on the Moon means building a new kind of community with its own rules, dynamics, and values. How will lunar resources be owned and managed? Who decides how to divide, exploit, or preserve them? Even today, international regulations are vague and lacking. The 1967 Outer Space Treaty prohibits national sovereignty over the lunar surface but offers no effective tools to regulate private economic activity. The risk is that, without a new shared legal framework, a kind of lunar Wild West may emerge, dominated by monopolies and unrestrained exploitation. Some experts propose establishing a supranational space authority, modeled after the UN, to manage the Moon's resources as a common heritage of humanity. Others imagine that alliances between public agencies and private consortia will de facto define the new rules. In both cases, the challenge will be to balance innovation, justice, and sustainability, not just environmental, but social as well. Then there's the not-so-minor issue of identity. What will it mean, 20 or 30 years from now, to be a lunar? How will human psychology change when living for months or years in an alien environment, far from Earth, without blue skies or trees, immersed in absolute silence interrupted only by the beating of one's own suit? Some psychologists and anthropologists are already studying early data from long-duration missions on the ISS, trying to predict the cognitive, emotional, and behavioral effects of life on another celestial body. And the first simulations of lunar habitats on Earth, in extreme environments like Antarctica or Hawaii's volcanic deserts, show how crucial it is to design spaces that are not only functional but also psychologically livable. Unsurprisingly, some of the most surprising collaborations in this sector involve visionary architects, wellness designers, and even artists. The goal isn't just to build operational bases, but to create environments that inspire, stimulate creativity, and allow inhabitants to feel part of something greater. Because the hardest challenge, in the end, won't be technical or economic, but human. transforming the Moon from a hostile and inhospitable place into a vital, meaningful, deeply personal space. This vision is also driving major educational and cultural projects tied to lunar colonization. Imagine a lunar school where young people from around the world study astrophysics, environmental engineering, and space law while gazing at Earth suspended in the black sky. Or a library carved into regolith, an archive of human civilization designed to withstand millennia. In this scenario, the Moon is no longer just a logistical platform or a mining deposit, but a symbolic place, an extension of our cultural horizon. Of course, all of this also comes with enormous risks. A miscalculation, an unexpected solar storm, a diplomatic crisis among rival nations could jeopardize years of work and billions in investments. And yet, never before has humanity had the tools, knowledge, and will to face this challenge. Because colonizing the Moon is not just about exploration. Ultimately, it is an act of self-definition. Who we are, where we want to go, what we are willing to build. And so, as the first pressurized modules are assembled, as rovers begin mapping mineral deposits and solar power stations start to shine on crater ridges, a new chapter of human history begins. One in which the Moon is no longer just a romantic destination or a symbol of conquest, but a home to build together. An antechamber to our interplanetary future. A laboratory for our evolution. And perhaps, the first concrete step toward a day when the entire solar system becomes an integral part of our world.